the first objective for Chapter 18 says, know what factor determines if an acid or base is considered strong or weak. And that's a little bit simplistic for what all you should actually know, because Section 18.2 had a bit more to it than that. So first of all, it's an acid if what? What do acids do in solution? They lose hydrogen. Whether you're thinking about it from Arrhenius or Bronsted-Lowry, if it gives up hydrogen ions in solution, while a base either gives up hydroxide or takes hydrogen, or both often are happening. So first of all, you should realize the difference between an acid and a base. That's an assumption that this objective's making. It's, you know, acids are the hydrogen donors, bases are the hydrogen takers. So then the second thing is, if it's a strong acid or base, what does that tell you about it? They what? It has a weak bond. Have weak bonds. So what happens when they're in solution? Yeah, they totally dissociate. Totally dissociate or ionize in solution. So that also means so strong acids and bases have a lot of ions available in their solutions. Either H plus or the OH minus. Which means they'll be more conductive, more reactive, and their pHs will be further from 7. Bases will be high, acids will be low. But they'll be out to the extremes of the pH scale. Also means that as far as an equilibrium constant, you really can't calculate one. But you can use an equilibrium constant use equilibrium constants now called Ka, oops, or Kb, depending upon whether you're talking about an acid or base, to show just how strong or weak an acid or base is. If there's no Ka or B, then we assume it completely dissociates. So strong acids, bases are shown with a single arrow to show a complete reaction. But weak acids and bases have the double arrow and are considered reversible. In fact, most of them have an equilibrium far to the left. They barely dissociate at all. And most acids and bases are actually weak. There are very few. I can only think of 8 total acids and bases that are considered strong. 3 acids, 5 bases.